How do you do wherever you are, whenever you are? We are doing functions here in the simplest way possible. These are the functions for grade 12 and grade 11, as well as metric rewrite. Welcome. So functions, we can also call them graphs. Now for grade 12, we need to differentiate between a graph and a function. More on that later. First things first, we know that a graph is a relationship between x and y. We have the x-axis here, and then we have the y-axis. This is our Cartesian plane, guys, and let's understand it in more details. Right here, where the x-axis and the y-axis are meeting, we call it origin. At origin, the x value is 0 and the y value is 0. So the x-axis is also called line y is 0. Why? Because at the x-axis here on the origin, y is cutting through 0. In the same way, the y-axis is also called line x is equal to 0. And we have another important line, especially for grade 12. Okay, let's see this line right here. The line that is cutting through the origin here. And then this line, we call it line y is equal to x. Now, so we're going to look into 5 types of graphs. Okay, let's see. 5 types of graphs. Five types of graphs. You can even try to list them all before I list them. Number 1, that will be linear function. Linear function, what we also call straight line. It's a straight line. So this is a graph that we're gonna see going upwards like this, or going down like that. The second one will be quadratic function. Also known as parabola. Okay, this is a graph that's gonna give us a happy face like this, or a sad face. Okay. Number 3, that will be hyperbola. It's a graph that's always trending for asymptotes. So it's gonna appear in the first quad and reflect in the third quad, or like this. So no stress, guys. All these shapes, why they're going up, why there's a smile, why there's first quad, third quad, everything, we're going to explain why later. For now, we are just listing the graphs. Number 4, can you guess? Exponential. It's an exponential function. So this is a graph we are going to see curving upwards like this, or curving downwards like that. And number 5. So this one, of course, is for grade 12 only. So that will be inverses. Oh yeah, so we have linear function, quadratic function, hyperbola, exponential function, and inverses. Okay, now watch this. The total allocated marks for paper 1 grade 12 functions, they are plus or minus 35. And they're going to ask different types of questions. But this is something interesting. The questions may appear to be so many, but believe me when I say there are only 4 types of questions. 4 groups of questions. 4 categories of questions. So the first type of questions in graphs will be sketching questions. So this is where you're going to be sketching either a hyperbola or exponential function. For grade 12, even the inverse, or either one of these graphs we learned, we are going to get ready to sketch them. The second type of question will be equation question. So a graph will be given, a sketch will be given, and then sometimes a graph doesn't have a complete equation. So they might ask for the equation of the graph. The third type of question will be properties. So a lot of questions are based on properties, or what we also call characteristics of a graph. Characteristics like what? Turning point. If there are 2, maybe they can ask about a point of intersection. Characteristics like asymptotes, axis of symmetry. It's actually a number of them, but don't stress, there are not too many. When we get there, I'll give you the list of properties. And the last type of question, which is number 4, that's going to be reading of question. So in reading of, what are we talking about? Imagine, let's say you have a graph like this. So this is the x-axis, the y-axis. And then let's say our graph is a very happy face graph here, which is a parabola. And then it's going up. So now, the reading of can be questions like what? Domain. Maybe they can say, okay, write down the domain of this graph. Let's call it f. Write down the domain of f. Now, to write the domain, you're going to have to look at the graph and see how far the graph is going to the left, how far is going to the right. You see? Questions like range, those are reading of questions. Questions like what? Let's see. Let's say they give you the x-intercept here, which is A, another x-intercept B. Then they tell you that, okay, right here, A is cutting at -2, B is cutting at +1. And they ask you for the length of AB. We know that here we have origin. So from A to B is going to be how many units? We are not doing the questions yet, but the length of AB, you are just going to read that, okay, from 0 to A, these are 2 units, ignoring the negative sign. And from 0 to B, that's 1 unit. So 2 units plus 1 unit, AB will be 3 units. You see, that's reading off. You are looking into your graph and you are reading off the answer from the graph. In some cases, you will be reading, let's say, your answer from an equation. One of the popular questions where you read off, let's say they give you a hyperbola equation like this, and which is y is equal to a over x minus 1 plus 3. Then they ask you for questions like what? You guess right. The equations of the asymptotes, where you will say, okay, equations of the asymptotes, I have to solve the bottom here and change the sign. X is equal to 1. And then for the y value of the asymptote, we are going to get y is equal to 3. You see, that's a reading of question. How did you do it? You simply look at the equation and you read off the answer from the equation. So how many types? Number 1, sketching. Number 2, equation. Number 3, characteristics or properties. And number 4, reading off. So when you practice functions, guys, let's make sure we strategize. You tell yourself that, okay, let's say today on Monday, you are practicing how to sketch a graph. The following day, you practice how to calculate the equation of a graph. The other day, you practice all the properties questions. The other day, you practice how to read off the answer from either the graph or the given equation. Oh yeah, let's start with sketching questions. We are going to sketch all the graphs. We are not leaving anything out. All the types of graphs, starting with our linear function here. So guys, in all the questions, you know, in my content, I will be showing you how to start a question, how to continue, and how to finish. Imagine when you know how to start, how to continue, and how to finish, nothing can stand on your way to level 7. All right, let's start with linear function. So let's see how to sketch a linear function. How to sketch a linear function. Now, a linear function, firstly, it's a graph which is defined by this equation. Y is equal to mx plus c. So before we do the example here, we are starting with the information first, guys. Knowledge is power. So we are getting some knowledge about how to sketch a linear function quickly. Let's see what we have. So y is mx plus c is the general equation. So a straight line, firstly, when you sketch it, you have to predict the shape. So that's going to be your step 1. Okay, let me write it using a different color. Your step 1 will be predicting the shape. Now the shape is determined by the sign of m here. Just to be clear, to remind you, m represents gradient, the slope of the graph. So here we have m, which can be a number that is what? That is greater than 0. In other words, it's a positive number. And if that's the case, the linear function will be the increasing function, like this. And if the gradient is a number which is less than 0, your graph will be going down. It's a decreasing function, like that. That's about the shape. Like here, when we sketch here, you see what we have here? We have y is equal to negative half x plus 3. So this is telling us that, okay, the value of m is equal to negative half. In other words, our m is less than 0. It's a negative number. So when we sketch our graph here, it's gotta go down. And step 2. Remember in the intro, I said a graph is a relationship between x and y. So in a lot of cases, it's gonna cut the y-axis and it's also gonna cut the x-axis. So we want to know where our straight line will cut the x-axis and where it will cut the y-axis. So in step 2, we find the intercepts. Okay, let me make it clear. You guys will get used to my handwriting. At first, it's going to make you feel dizzy, but you're going to accept it later. So starting with the x-intercept, it's a place where the graph will touch the what? The x-axis. So that's the x-intercept. So at the x-axis, the value of y is 0. So when we find the x-intercept, we'll let y equal to 0. Then we go to the y-intercept. That's a place where the graph will cut the y-axis. So we let x equal to 0. Then the final step, we do what they asked us to do. We plot our points and sketch. Now, now let's see. This is our example here. Firstly, the graph will be going down like that. And next, let's see, we have to find the x-intercept. At the x-intercept, y will be 0. So remember, this whole expression here is equal to y. So we're going to take the whole thing here and equate it to 0. Negative half x plus 3, and we'll equate it to 0. Now, for simplicity, let's multiply negative 1 with x to get negative x over 2. Then take 3 to the other side. It's going to become negative 3. We are preparing for cross multiplying. So 2 will multiply negative 3. This negative x, remember this is over 1 right here. So we're going to cross multiply. So negative x times 1 will be negative x. 2 times negative 3, that's your negative 6. Then we divide both sides by what? By negative 1 here, guys. So when you divide negative x by negative 1, you get positive x. And then here you get positive 6. Therefore, remember, we don't leave it like this. We are looking for a full point, which will be 6:0. Okay. Let me create some space here. Next, we go for the y-intercept. So this is a place where x is equal to 0. You go to your original equation there. Where there is x, we are going to put 0. So y will be negative half. So where there is x right there, we hoist some 0. That's plus 3. Of course, that's going to be a 3. And by the way, just to add some information here, remember, your general equation is saying y is mx plus c. So this c here is always a constant number, which represents the y-intercept. So in a lot of cases, you are also allowed to just go ahead and avoid the calculations here and just write, okay, the y value is 3. So the y-intercept as a point will be 0:3. That was step what, guys? That was step 2 right here. Now it's time to plot because we got everything we need, guys. Let's see. We have 6, 0, and 0, 3. So you can use your ruler just to be a bit accurate, even though it's not an accurate graph, you know. We just want everything to be straight, just for encouragement. Imagine your graph looking like it's tired. Okay, this is the x-axis, this is the y-axis. And then this is our origin. According to this, the graph is cutting at 6 and 3. It's cutting on the positive side of the x-axis and the positive side of the y-axis. So let's draw a graph like that. Here we go. Okay. So the graph, of course, will be going up to infinity. So we just put the arrow there and then up to the other infinity. And then here we label 6 is to 0. And then the y-intercept, remember, is 0 is to 3. 0 is to 3. And checkmate. Now, just pause the video and try this one out. This one is saying sketch line x is -3. So sometimes they can throw in a graph like this just to see what you're gonna do. So here we have the y-axis, the x-axis, 0. So this graph is telling us that, guys, x is -3. So -3 will be on the negative side of the x-axis here. So it's a line which is cutting the x-axis at -3. Nazo, here's another one. Here's another one. Line y is -3. Okay, same situation, but this time we have line y is -3. So on the negative side of y, which is below 0 here, we go and sketch our beautiful line. Where is it? Here. Make sure the line is horizontal and make sure the line is cutting through -3 at the y-axis. So that's line y is -3. That's line x is -3. Now let's sketch a quadratic function, aka parabola. Now this is a graph that when you sketch, sometimes it's just gonna be happy, like this. Sometimes it's just gonna go sad on you. But happy or sad, when you sketch it, you're always gonna smile because you will know how to start, how to continue, and how to finish the sketch. These are the steps we need to follow. Firstly, in step 1, we are gonna predict the shape. We just wanna know whether it's gonna smile or it's gonna be sad. Okay, now let me create this space here, because guys, this graph is generally defined by this equation. Y is ax squared plus bx plus c. There are other ones we'll talk about, but let's start here. Okay, so when you look at a, b, and c, guys, they are gonna be real numbers. Just like here in this example, we see that, okay, our a right here is 1, our b here is -2, and c is the constant number right there, which is -3. So a, b, and c will be real numbers. And if it happens that the sign of a is a positive number, your graph is gonna be a happy face. It will give you this smile. That's what happens when you have a positive mentality, a positive attitude. Yeah, you will end up smiling. Things may start maybe hectic, but at the end, who knows, you will be smiling. So this is what we call concave up. It's like the mood is up, then we smile. Oh yeah, and then if it can happen that our a is less than 0, that's gonna be a concave down. That's concave down. Okay, let's write that down. Concave down. So in this case, the mood is down. So we show a sad face. That's step 1. So in our graph here, in the example, we know that, okay, since a is +1, we know that positive 1 is greater than 0. So when we get to sketch this graph, it's gonna be a happy face, guys. Oh yeah, let's continue. Now, after this, in step 2, we are gonna remember that, okay, a graph is a relationship between x and y. Therefore, in a lot of cases, it will cut through the x-axis and also through the y-axis. Then we're going to find the intercepts. Now remember, when we find the intercepts, we are actually finding x-intercepts. And then in this case, we are saying intercepts because they're going to be 2. X is squared, so that's 2 x-intercepts. So we're going to let y equal to 0. That's how we find the x-intercept. And then we must also find the y-intercept, a place where the graph will cut through the y-axis. We let x equal to 0. Step 3. In step 3, this graph is unique when you compare it to other graphs in paper 1 functions. This graph is unique because it can turn. Look at this. It has a minimum value where it's turning here and a maximum value where it's turning. So we're going to have to find the turning point. Turning point. Sometimes turning point, they can just call it stationary point. When we get to calculus, that will even make more sense why they use the word stationary. Okay, now we have a point here. Remember, a point consists of the x value and the y value. So we're going to have to start by finding the x value of the turning point. How do we do it? We say x is equal to negative b over 2a. Remember the equation of the original parabola. It shows a, b, and c. So we substitute according to whatever is given. So this is how we find the x value. Now, so next we go to the y value. Now, the good thing about the y value, guys, y depends on x. So whenever you have the x value available, you simply do what? Oh yeah, you substitute the x value into original equation. Then you're gonna get your lovely y value. We have everything we need, guys. You know what happens next? We just sketch. Let's go there. This is our example, the first example. Let's see what we have. Already the shape is going to smile because a is positive. Now let's find the intercept, starting with the x-intercept. We let y equal to 0. So your whole expression here is equal to y. So you will take your expression, which is x squared minus 2x minus 3. You equate it to 0 because y is 0, guys. So after that, what do you have? You have a quadratic equation. So this is why it's so necessary to master algebra, which is question 1, paper 1. There is a quadratic equation question there. So when you do quadratic equations, this is the standard form. After standard form, we factorize. If there are no factors that are whole numbers, you just use the quadratic formula. So here we are going to win because we are here to win, guys, all the way. Now, that's x and x. The factors of 3 will be 3 and 1. How do we get negative 2? The middle term, we say negative 3 plus 1. Therefore, x is equal to 3 or x is equal to -1. But as a full point, we write it as 3:0 and -1 is to 0. That's with the x-intercept. Let's go to the y-intercept. We have y-intercept, and at the y-intercept, we let x equal to 0. So if this video is helping you guys, you might wanna like and subscribe. We have y-intercept, so we're gonna let x equal to 0. Now remember, like in the case of a linear function, the last number here, which is a constant, will always be your y-intercept, provided the rest of the terms are what? Are written with x, because when you put x is 0, everything is gonna be 0, guys, and you're gonna be left with c. But we can show it because, hey, what's the rush? Okay, in our original equation there, here we're gonna write x squared minus 2x, but it's gonna be 0 in the place of x, minus 2 in the place of x, 0, and then what is y there? The y value will end up being -3. Therefore, we write 0:3. Next customer, please. What is next? The turning point. Okay, let's do it alongside here. The turning point. Now, with the turning point, we are looking for the x value first, because a point consists of x coordinate and y coordinate. So the x value of the turning point, we use x is -b over 2a, which is equal to, let's see, what is our b here? We've already written that down as -2 over 2. What is our a? A is 1. So use your calculator, you will get x is 1. So you write x is 1. Next, the y value. Okay, right. How do we write the y value? The y value is going to be written based on the x value. So we're going to substitute x is 1 into the original equation. Right. So the original equation is y is what? X squared minus 2x minus 3. So in the place of y, we will substitute the x value we got here, which is 1 all squared minus 2 into x minus 3. So where this x, you are putting 1, guys. Use your calculator. Let's see, 1 minus 2 minus, so that's gonna be -4. So therefore, x is 1, y is -4. The turning point will be written as 1:-4. What do we have? Everything, guys. We have the shape, which is the smile. We have the what again? We have the x-intercepts. We have the y-intercept, and we have the turning point. Let us plot our graph. So when we plot, let's always and forever label the x and the y axis. Okay. Here we go. So we're gonna write y here, x here, 0 there. Our graph, it's cutting at x is -1. -1 is not too far from 0, and x is 3 on the positive side, which is a bit further. So here, which color? Okay. This is beautiful, guys. A beautiful smile. It makes your day. Here we label x-intercept is -1, and this side x-intercept is how much again? Is 3. Is that right? Yes, it's 3. And the y-intercept here is -3. It's important we label everything. And here we have our turning point. There it is, which is 1:-4. That's how you sketch a parabola. And checkmate.